friends, I wanted to make a quick video to go over number 3 in your packet. This is going to show up tomorrow on the quiz, something like this, where we have one graph, one region, and then I ask multiple things about that. So let's go ahead and get started. The very first thing that I would do is make sure that you know which of these curves corresponds to which function. So let's just think about this. F of x looks like 8x cubed, so that's just a regular cubic function. We're starting at the origin, it's increasing. This means that this function is function f, so this is f of x. Over here, g of x equals sine of pi x. All right, well, think about a sine curve. It starts at the origin, it increases, then decreases, increases, and decreases. So I know that my higher function is g of x. All right, so here we go. Write an equation for the line tangent to the graph of f at x equals 1/2, at x equals 1/2. Well, here they gave us the point. It goes through the point 1/2, 1. And then we're looking for the equation of the line tangent to that. So I'm expecting a positive slope, and that is going to be able to be calculated using the derivative. All right, so let's think about this. If f of x is equal to, what did I say that was? 8x cubed? 8x cubed? 8x cubed. Its derivative, going all the way back to differentiation here, well, 8 times 3 is 24, and that will be 24x squared, 24x squared. And if I'm looking at this, write the equation for the line tangent at x equals 1/2. All right, well, f prime at 1/2 is going to be 24 times 1/2 squared. All right, well, 1/2 squared is 1/4. 1/4 of 24 is 6. So for our answer, we have our slope. We have a point. It goes through the point 1/2, 1. So then I am lazy. I'm just going to write this in point slope form. We have 6. We want to shift to the right by 1/2, so minus 1/2. And then finally up by 1, plus 1. So that right there is the equation of the line tangent to the graph of f at x equals 1/2. All right, so next one, find the area of R. Find the area of R. So in this one, I have a higher function, I have a lower function. In this one, I'm going to go ahead and differentiate this with respect to x. It's going to be kind of easy to find the distance between those. All right, so here we go. We are integrating from my x values. I'm going from 0 to 1/2. So I'm going from 0 to 1/2. My higher function is g of x. My lower function is f of x. So I have my integral from 0 to 1/2 of g of x minus f of x. And we are taking our derivative, or our integral, with respect to x. All right, looking at this, we're going from 0 to 1/2. I'm going to go ahead and write in these values. G of x is sine of pi x minus 8x cubed is my f of x dx. All right, taking my antiderivative here, well, my antiderivative of sine is going to be a negative cosine of pi x. And then careful, I have a times pi here. So if I'm taking the antiderivative of that, I'm going to have to divide by pi. And if you want to double check, if you want to do your chain rule here, you can verify that this has a derivative of sine of pi x. Minus, this is going to be a little bit easier one. This is 8x, we're adding 1 to the 4th, divided by 4. And we are evaluating this from 0 to 1/2, 0 to 1/2. All right, so for this one, I'm not going to waste video time doing the arithmetic here, but hopefully you can just trust me. This comes out to be negative 1/8 plus 1 over pi, 1 over pi. All right, and remember, when we are evaluating here, if you were having a brain fart moment, as long as you don't have any x's left in this, you can write a full, if this is the free response, you can write a full expression here. You could have just left this as negative cosine of pi over 2 divided by pi minus, you could just have that evaluated at 1/2 minus evaluated at 0. Just left that entire expression and that would have been acceptable as well. So if you're having a brain fart moment, you know who you are, you can leave it as that. However, be careful with parentheses. All right, last one. What is the maximum distance between the curves of f of x and g of x between x equals 0 and x equals 1/2? You must use a derivative to justify your answer. All right, so as soon as you see the word maximum or minimum, your spidey senses should kind of be going off saying, ooh, this is probably going to be a derivative. All right, so an expression for my distance. The distance between these two is simply, if I just subtract these, g of x minus f of x, that is the distance between those two. So my distance of is g of x minus f of x. All right, and if I go ahead and write that expression, that is sine of pi x minus, get that other parenthesis in there, 8x cubed. All right, now if I'm looking for what is the maximum distance between 0 and 1/2, well, I'm going to look for the derivative. All right, and if it is a maximum, I'm looking for the derivative to be going from a positive value to a negative value. And if there are multiple ones, or if there are multiple points where we have a derivative that's going from positive to negative, well, then we would have to test those right up here. All right, so let's go ahead and calculate the derivative here. And this is graphing calculator allowed. So this is going to be we're just going to graph it. All right, derivative of sine of pi x. Well, the derivative of sine of pi x is cosine of pi x. And then don't forget your chain rule, there is times pi. And finally, derivative of this is 8x cubed. If I bring that in front, that is 24x squared. And this is going to be what I graph. This is going to be what I graph, and I'm looking for a place where it goes from a positive to a negative. All right, when I graphed this, this occurred at one point. This occurred when x is approximately 0.286. All right, now be careful here, be careful. And I'm gonna go ahead and visualize that up here. Well, this doesn't really come as much of a shock. If I'm kind of looking here, my distance starts off at 0, it comes back to 0. This distance, it looks like we're increasing, looks like we're still increasing, and it looks like our maximum is going to be about halfway in between those two, not exactly, but this x value is approximately 0.286. Now be careful, it is not asking what is the x value, it is asking what is the maximum distance. So to finish this problem, you do need to evaluate what is the distance at this x value. And when we find that the maximum distance is approximately 0.595. That is the max distance. All right, must use a derivative to justify your answer. This is a maximum distance because this is when our derivative changes from a positive value to a negative value. From positive to negative at x is approximately 0.286. All right, now I'm curious if anyone is yelling at me, what about the endpoints? In this one does specify between x equals 0 and x equals 1/2, so we don't really need to test our endpoints because we're not including those. But even if we did include the endpoints, it's kind of a duh statement. The distance at 0 is 0. The distance at 1/2 is 0. So really, even if we did test the endpoints, it's not going to be one of those two values. All right, so quick recap here. Write an equation of the line tangent. That's easy peasy. We did that last semester. You should be good at finding that. Find the area. This is our new information for this unit. Basically, only thing that could really trip us up is arithmetic. And then finally, as soon as we see maximum or minimum, we are looking at finding the derivative, figuring out what type of critical value we're looking for. For a max, we're going from positive to negative. And then our justification is our derivative is either changing from a positive to a negative or a negative to a positive at that value. And if there are multiple ones, you'll have to test them and then figure out which one is the correct one. All right, have a fantastic Wednesday.